Any questions on that? Good. Any questions from the live audience? No live audience. Okay, so I think good there. So we can get into some problems later from the back of the chapter. Let's do some trig identities. So we said tangent was what? Opposite over adjacent, right? And we also said that tangent is actually sine of the angle. So the tangent of an angle is the sine of the angle over the cosine of that same angle, right? So that's a trig definition there, trig identity. And so the cotangent is going to be cosine of the angle over sine of theta, right? Okay. Here we've got Pythagorean identities. And if you remember this, and sine squared theta plus cosine squared theta equals what? 1. Okay. So remember that. Remember the definition of sine and cosine. And if you remember those, you can work out these trig identities. 1 plus tangent squared theta is secant squared theta. And 1 plus cotangent squared theta is cosecant squared theta. Okay. So let's see, can we work that out? So sine squared theta plus cosine squared theta is 1. 1 plus tangent squared theta is secant squared theta. 1 plus cotangent squared theta is cosecant squared theta. So these are also 3, and actually I have a sheet I'll hand you guys. Did you guys get the unit circle? No, you didn't, right?
H, is that an H?
Where?
On the bottom 2 lines? Or is that like?
1,
No, it's 1
oh,
plus.
1 plus cotangent squared theta.
Okay.
So this is the unit circle. And later on I'll have some handouts for that. That'll have these formulas on it when you have, later on when you actually have to use it. But let's see, can we show, if we use this basic, this is the, I think it's a basis for trig. So can we show that, can we use that to make the other one? So 1 plus tangent squared theta, so 1 plus tan squared theta is what? Well, that's going to be 1 plus, what is tangent squared theta? Well, that's sine squared theta over cosine squared theta, right? And we're trying to get it into secant. What is secant squared theta? Secant squared theta is sine, cosine, tangent, 1 over cosine squared theta, right? So that could be 1 plus sine squared theta plus secant squared theta, right? 1 plus tangent squared theta. So tangent is sine over cosine, so we square it. Sine squared over cosine. And, oh, no, sorry. Not plus, but times. Right? Well, 1 is sine squared plus cosine squared. Sine squared theta plus cosine squared theta plus sine squared theta secant squared theta. Right? What if I factor out a sine squared? I'm going to get sine squared theta times 1 plus cosine squared theta. And what do I have? Can I factor out anything else? So I'm trying to get this into just secant squared theta, right? What else can I do? We don't really do this yet, but in the next section, this is a lot of what we're gonna do. We're gonna use just like basic trig functions to prove other trig functions, okay? So, 1 plus secant squared theta. Did I get that right? 1 plus sine squared. Sometimes you can work backwards too from secant squared. Because this equals secant squared theta. So this is actually one I've done. I haven't done this in a while. Sine squared, cosine squared. All right. Well, I'll pick up on that. I don't want to waste time looking over it, but you can prove using this and this. You can prove these trig functions, right? So we get to that. It's lots of fun, right? It's pretty enjoyable. I think they're fun. Okay. I wonder if I wanted to. Let's see, some application problems. Okay. So just save those in your memory. Okay. Actually, remember, what did I say? Save the basic 6 trig functions, and sine squared theta plus cosine squared theta is 1. So remember those. Okay. And the other ones, if you remember those, but you can use those 2 basic ideas to come up with that. Okay. All right. So applications of a right triangle. So you've got a surveyor 115 feet from a base of the Washington Monument. So you've got the Washington Monument. Oh, welcome back. Okay. So Washington Monument here is 115 feet away. And we're trying to figure the height. Sorry. So here's the height, here's the ground. He's standing here, 115 feet. And he's looking at an angle of 78.3 degrees. How tall is the Washington Monument?
I can do this. Like 2 seconds.
Should I let Madison go? Go, go, go! So what are you gonna do?
What?
How do you figure it out? So remember this? This is my angle,
That's
right?
700 and.
78.3
Oh,
degrees.
78.3.
So theta, 78.3 degrees. Okay. Height of the monument. I'm trying to figure out the height of the monument.
And we have the distance we are away from the one.
You have the distance you are away. and you have the angle. I'm looking at the angle from the bottom to the top, right?
Equals.
Say what? So remember we have our 6 trig functions, right? So I've got which trig function applies to this angle and the information we have. That would be the, starts with the C. Okay. About to freak out that it wasn't recording. Cosine. Cosine of this angle is what? Do you cosine or do you want to do
I did tangent.
tangent? Yeah, right?
I also got 552.
552 is good. So tangent of 78.3 is equal to what? Height of the monument over sine over cosine, right? Opposite over adjacent. 115. And your calculator, so you pull out your calculator and you punch in tangent of 78.3.
And then you get 4.8.
4.8?
Yeah.
Yeah. So I get 4.829, right, is h over 115. So you multiply both sides by 115. And you get height equals 555
What?
feet, right? What'd you get? 500.
552.
And so you round it off. Yeah. So you round it off. You're gonna be off by a hair, right?
Okay, I technically was right.
Did you watch Spider-Man? Uh-huh.
Yes.
Was it? No, it wasn't Spider-Man. It was the.
No, Spider-Man.
Was Spider-Man? Yeah, when he's in the monument. Yeah.
Yeah.
So. He's off by 3 feet. He's not fitting through that window. It's gonna be spider splat. Right on the side of the building there.
Poor Tom Holland.
That was the Vulture. Yeah.
No.
So. Vulture is actually a good economic movie too. Out of Frame, the stuff I mentioned, Out of Frame, the feed videos are pretty good. They did one on the Vulture. And remember the Vulture was created because he invested a ton of money in this company to come and clean up the city. And then the government comes along and confiscates it all.
Yeah, and so
And
he
gives the
steals back
contract.
his alien.
Yeah, so he gives the contract to their friend Iron Man,
Yeah.
right, who makes billions on it. And he takes the technology they find.
Because it was after the Battle of New York.
Yeah. Yeah, so a pretty good movie and really a realistic, totally realistic movie.
It's 100% realistic.
At least in the concept of why the Vulture would exist. It's very realistic, so. Like as far as villains go, he's the most realistic villain in the MCU. MCU, they call it. Just because he's somebody who goes, he's a good guy, he invests money and the government comes confiscates everything. And then he says, well, you know what, we're just gonna make money some other way then. Right? So I thought it was kinda cool. I should have done, yeah, it's a pretty good movie. All right. So these are the kind of applications that you can use this for, right?
Now I can discover how big the earth is.
Yeah, so guys go out in the parking lot. Go out in the parking lot. Stand at the base of the fence over there. You gotta look and measure the angle from the ground to the top of the building, right? And then find out the height of the building here. You would have to figure out the distance from here to there, and the angle when you look at the building, right? So, here, another one. arc sine yet. How did I get that? Oh, that's why. So I've got a 400-foot walkway from me to my house, me, home, and I've got a bike path that is unknown. And from the bike path to the house is 200 yards. And it's 400 yards for me to just straight cut through there. What is theta?
Oh, you did
So we don't do arc sine yet, but you don't need arc sine for this problem. In fact, you don't need your calculator really.
Oh.
Okay, so,
Yeah, 0.5.
yeah, so sine of theta, right, sine being opposite over hypotenuse, equals 1/2. So theta is, just remember, unit circle. Beep, 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 beep. Theta, 30 degrees. Okay. Remember, sine of 30 degrees is 1/2.
Oh, is that 200?
Oh, yep, 200.
Oh, I totally thought that said 20.
200. 1 over 30. Could be 20. 200 yards.
I definitely thought 240.
220 on your calculator?
Yeah, because I thought that said 20.
Okay, I don't know if that's right. Let's see. That was 20.
Okay, well, I didn't write that.
That would be 0.0009 degrees. But no. Okay.
So, if theta's 1/2, it's always gonna be 30 degrees.
Well, if the sine of theta is 1/2,
Yeah, the sine.
then theta would have to be 30, right? And that goes back to just the unit circle. So just looking at quadrant 1, remember 30, I've got √3 over 2 comma 1/2, right? The cosine comma sine of the angle, right? And that refers to the x value and the y value, right? So this is 1, and so the cosine of x is this distance over 1, right? Theta, so cosine of 30 is √3 over 2 over 1, right? And then I've got the other one, which is 45, and that's √2 over 2 comma √2 over 2. And then I've got 60 degrees. And by the way, if I have a triangle that here, let's say this is 50 feet, and this is pi over 4, okay? What is this? Well, I said the cosine, or the sine, right? So the sine of pi over 4 equals this over 50, right? And the sine of pi over 4 is √2 over 2. So √2 over 2 times 50 is y. Now what's the significance of 50? 50 is whatever that hypotenuse is, right? So you just take the sine or cosine of the angle times the hypotenuse, and you're going to get the legs, right? And so these are the angles you can memorize, right? So what is that, 25 √2? So this is 25 radical 2, and what's this like? Well, 25 radical 2, right? Same, it's a isosceles triangle, 45 degrees. Right. Okay, any questions you guys had on that?
Peace out.